Okay, so the next presentation is on what MUBAS has been doing in terms of research. MUBAS, as was mentioned by the DVC, is an institution that has just been born from University of Malawi with the linking of the universities that, or colleges that formed the UNIMA at the time. So we have now Malawi University of Business and Applied Sciences, Chancellor College as a constituent college has now become the owners of UNIMA, which it had from the beginning. And then we have Kamuzu College of Nursing and the College of Medicine as the new University, Kamuzu College of Nursing, Science and Technology. So yeah, that's our iconic building, which is the face of MUBAS today. Next slide. Yeah, so MUBAS has been doing research, and the main area that has been focusing on is low-cost building materials that they can withstand various adverse effects in construction. And the earthquakes and the floods have been one area, and we have worked with our students as well as external partners to see how best we can be able to deal with these hazards. And the main issue that we have looked at include how a building can be laid out to ensure that it can stand forces. As we know that a building form is the starting point. When you look at the materials you can use for construction, you must look at it in relation to the structural form that you are going to use. And in the particularly flood-prone areas, we have looked at what level we should have the floor where people actually do their activities. And in flood-prone areas particularly, what is critical is to look at observing the levels at which floods have reached in the past. But as it would happen, like this year in Malawi, we had the cyclones, starting I think from 2019, we had the cyclone, and this year of cyclones. So I think with climate change, we expect to have these activities to be predominant. And so we have an interest to ensure that as researchers, as teachers, how do we ensure that we transfer knowledge to our learners so that they can be able to have a good start when they start their building. Of course, we know that one of the challenges we face is that people living in flood-prone areas, this is that they don't want to move away from where they grow crops, and so it becomes a problem. So in terms of site location, it is quite tricky there. And also, we have tried to look at traditional construction. This has the appropriate cost-effective approaches. And so this has formed part of our studies here. Materials that we have looked at, like bricks, bamboo, they are materials which are prone to moisture ingress. And so we have tried to look at how best to treat them as part of our focus. In terms of earthquake, the major issue that we have looked at is the transfer of forces. We have looked at the bamboo as a construction material, but then of course, as we know, bamboo has some challenges, particularly with the treatment to ensure that it does not rot. But it is one material that is being promoted to ensure that there is continuity in the practice. Last week, we had a meeting at the Malawi Bureau of Standards, looking at a standard for bamboo construction. So it's a material that is being promoted. We don't have natural resources college here, but the university responsible for agriculture and forestry, they are saying that, at least from the meeting we had, that they're trying to promote growing of bamboo. In the past, I had the impression that the bamboo was not being seen as a tree, but as a grass, because forestry research of Malawi, that's what they had said. But it appears that there is a future for bamboo construction. Therefore, with the standards in place, it must be able to be promoted. Next slide. Okay, so those are just the figures showing the experimental works that we have done, looking at formwork for bamboo construction, testing for bending, shear, okay? So very important, and the connection is very critical for bamboo. Next slide. And so we see again connections. We had that demonstration truss construction as part of our work, looking at construction using plywood as a mechanism to look at the connectivity that we can have. But definitely bamboo, looking at the deforestation that has taken place, and that bamboo can be harvested within 3-4 years. It is a potential material for construction. Okay, next slide. Okay, so with the University of Bristol, we have had now research starting from 2017 up to now, and we have looked at a number of areas, looking at the construction of residential houses. The pictures we thought with John was looking at the construction of residential houses. Now, the focus is on school buildings. And so with the school buildings, we have two areas that we are looking at the communities themselves, how resilient they are, and then the actual structural topologies, how the buildings can stand forces. And so we have this app here, which is the face of the app. And so if you got the app, you can look at, if you are solving a new building, then we could start there. If you are looking at the community assessment, you go there. And so with that, we are able to deal with the schools. Next slide. And so basically, for community resilience, Innocent will talk about the other aspect, which is the building topologies or school topologies. But from the community resilience side, when we went to a school, we were able to target the head teacher, 2 teachers, 2 school management committee members, 5 learners, and 5 parents. In most schools, we're able to get all those, but secondary schools, as we know, they are boarding, so we would not sometimes get, particularly the parents, would get the other stakeholders. And in each district, as I mentioned earlier, we're targeting 1 primary school and a secondary school, 1 primary school and a secondary school. We administered the questionnaire surveys, and these ones, first round, we had them using paperwork. In the second round, we had done app, as I mentioned there. And currently, we are looking at the data that we collected, but what is coming out clear is that there are issues to do with community resilience, and people said that from particularly only, for example, construction, because most of the schools that we visited, nearly all of them, they have 1 door. And so if anything happened within there, we may have to change the way we design our school buildings to have at least a minimum of 2 doors so that people can have evacuation routes. With this, I will pass on to Innocent. Next slide. Of course, that's how we're conducting our interviews with the practitioner or the participants. So that's just one illustration of how we're conducting the questionnaire survey, particularly the paperwork one. John, not John, Innocent, next slide.
Okay, thank you, Ignacio. For the structure surveys, we were doing visual inspection of school buildings across the country. And the objective was to come up with the topologies that would inform the modeling of the same. Next slide. Yes, so the method that was adopted was visual inspection, and the technique we used the mobile app, and this is the interface of the mobile app that we use to carry out this particular campaign. So we managed to cover the whole country. I should say 27 districts, because we have 28 districts in Malawi. We managed to cover 27 districts, and the total buildings that we were able to get the details were 206. Next slide. Okay, so the actual building assessment involved getting information about the school. That is the name, identification, student number, And we were also collecting technical data to do with the building characteristics, for example, number of stories, floor area, structural system, whether reinforced or unreinforced, and the type of material, and also retrofitting mechanisms on the structures. Besides that, we're collecting data to do with the seismic data. For example, soil category, whether it's local, stiff, or soft soils, and also vulnerability details to do with the damages, existing damages on the structure, whether there is moisture ingress in the wall, cracks, the shape, whether the structure is torsional sensitive, and also the quality of masonry as well as the ground slope. Next. Okay, so these are some of the buildings that we're able to get the details, and some of the observations included some cracks on the walls. Some buildings had the piers, link beams. Others, they were in a bad shape without any connections. So these are some of the buildings or the topologies of the building that we're able to get details. Next slide. Okay, so having collected data to do with the seismicity, vulnerability, and also the technical, we were getting additional structural details to do with the geometric characteristics, for example, openings, structural characteristics, and also facade restraining details. So the information of these aspects, we were recording them on the form, which is shown on the screen. And then we're also able to sketch some details that were deemed necessary to inform the modeling. Next slide. Okay, in terms of the measurements, for example, facade restraining details on the first picture, we're able to get details of the pier parameters, the length, the width, etc. And on the geometric characteristics, we're looking at the dimensions of the openings, for example, windows, the height of the sill, and also the height of the foundation. On the structural characteristics, we're looking at the size of building units. For example, if it's a brick, the size or the dimensions of the bricks, and also the overlapping of the bricks. And that information was recorded on the structural survey form. Next. Okay, just to get a summary of what we're able to collect from the campaign. As I've already said, we managed to cover 27 districts of the country, across the country. And looking at region by region, in the southern region, we managed to get the data from 114 schools, and in the central, we managed to survey 52 buildings or structures, and in the northern region, we did 50. So in terms of the structural system, the common type of structure was unreinforced masonry, URM3, followed by the concrete blocks, and also some reinforced concrete elements, as well as some other categories to do with the unreinforced masonry, like categories, for example, category number 5 and the category number 1 and also 2. So these are some of the structural systems that we're able to observe while we're doing the structural survey. But the most prominent one was an reinforced masonry structure. Next slide. Next slide. So I think You skipped one slide. Can you go back? Okay, yeah. So the other data that we collected was to do with this seismic condition. For example, the soil category. So all this information was processed by the mobile app. For example, on the soil category, the majority of the buildings were in the rocky and steep soil sites. Others were built on the soft sites as well as the medium soil sites. Now, on the seismic zones, there are 3 zones according to the app that we're using, and the majority of the buildings belong to zone Z2, and this is zone Z2 has got special characteristics. So it means this is where the most of buildings belong in terms of seismic zone. Next, I think next. Yeah. So so far that's what we did in the campaign to do with the structure survey, and I thank you for your attention. Let me hand over to Ignacio. Thank you.